Linear inequalities are treated the same way as linear equations for the purpose of graphing. The only difference is instead of just drawing a line, we are now shading a portion of the graph. For example, if we have x is greater than or equal to 4, that means that any values that satisfy x being greater than or equal to 4 would be solutions. It doesn't matter in this case what y is going to be, because we're only looking at the x. So pretend that this said x equals 4. Well, we learned that if it says x equals 4, that's a vertical line through x equals 4. So that would look like 1, 2, 3, 4. A vertical line right here. Now it doesn't say x equals 4. It says x is greater than or equal to 4. So that means that there are multiple solutions we could consider. If x was 5, we'd be happy. If x was 6, we'd be happy. And anything greater than or equal to 4. A couple things to notice here. It says or equal to 4, so we are able to use 4. Because we have this or equal to underneath right here, that tells us that we need to use a solid line when we draw our line to graph. Greater than means that we can consider anything greater than 4. So that would be everything over here like this. So we would shade our graph to represent greater than or equal to 4. Let's try another one. Y is less than x. Notice there's no or equal to here. There's no line underneath. That is just less than, which means that we're going to use a dotted line. So pretend this said that y equals x. Well, if this said y equals x, we could think about that as y equals 1x plus 0. And if we do that, we can see our slope is 1 and our y-intercept is 0, 0. We can use that information to draw our graph. So if our y-intercept is 0, 0, that's right here. And if our slope is 1, that would look like rise 1 over 1, up 1 over 1, like this. There we go. If we can connect our dots. There we go. Now we need to figure out which way to shade. In order to figure out which way to shade, use what's called a test point. A test point is just any point that you randomly pick. My favorite test point is 0, 0, but we can't use that as a test point because that is on our line. And we can't pick anything that is on our line as a test point. That won't help us out. We need to know which way to shade, so we need to figure out a different test point. So how about we just pick 0? Well, we can't pick 0, 0, so how about we pick 1, 5? There we go. So 1, 5 would look like 1, 1, 2, 3, 4, 5. So that's our test point. Let's give it a try. If we put 1 in for x and 5 in for y, we have 5 is less than 1. Does that work? Nope, that doesn't work. So that means that we're going to shade away from our line. Before we shade away from our line, let's double check. We were basing everything off of y equals x. Not really what we have. We have y is less than x. So we need it to be a dotted line. So let's go in and let's make this a dotted line. There we go. You can erase part of your solid line, or you can go in and draw dots to make it a dotted line. Either way, we need a dotted line. And what that means is we cannot use every point on the line because we don't have that or equals. Now we found our test point of 1, 5. That's right here. We found that didn't work. So that means that we need to shade away from our test point. So this would be our solution region. try again. So number 3, y is less than 3x plus 2. There's no or equal to, so this is going to be a dotted line again. But to get our graph drawn, let's pretend we had y equals 3x plus 2. From that, we can see our slope is 3 over 1, and we can see our y-intercept is 0, 2. So let's start with that information. Our y-intercept is 0, 2. So here's 0, 1, 2. And our slope is 3 over 1. So up 3, 1, 2, 3 over 1. 1, 2, 3 over 1. There we go. Let's draw our line. But we have a dotted line again. So let's go ahead and make sure that that is a dotted line, not a solid line. And again, you could put some dots on if you wanted, or you can erase part of your solid line to make it a dotted line. But it needs to be a dotted broken line. Then we need a test point. Well, this time 0, 0 is not a point on our line. See right there? So 0, 0 is not a point on our line, so why don't we use that for our test point? So that means we substitute 0 where we see x and 0 where we see y. So 0 is less than 3 times 0 plus 2. 0 is less than 2. That works. So if it's a true statement, we shade towards our test point, which in this case is this way. And then we have the graph of our inequality. Let's try again. Number 4 says negative x minus 2y is greater than or equal to 4. So first, we need to get this into y equals format. We have the or equals this time, so that means we're going to have a solid line. So let's rearrange this to get y by itself. So if we do that, we can add our x to both sides. Then we need to divide by our negative 2. Now be careful, what happens when you divide by a negative? Do you remember? We have to switch that inequality. So x divided by negative 2 gives us negative 1/2 x. 4 divided by negative 2 gives us negative 2. And we have to flip that inequality because we divided by a negative. So now we have a slope of negative 1/2. We have a y-intercept of 0, negative 2. And we can draw our graph. So starting with our y-intercept, (0, negative 2 is right here, and our slope is negative 1 over 2. So that means we go down 1 and over 2. Down 1, over 2. Down 1, over 2. And you can go for as many as you need. Draw our line. Oops. There. Now we need a test point. 0, 0 is my favorite test point, and it's not on our line, so let's use that. So let's substitute it back in. So we have the opposite of x minus 2 times y greater than or equal to 4. So let's see. The opposite of 0 is 0. 0 minus 0 is 0. So is 0 greater than or equal to 4? Nope. So that means that we shade away from our test point. So in this case, we shade this way. There we go. Let's try one more. Number 5, 3x minus 2y is less than or equal to 6. So same thing, we have the solid line this time because we have an or equal to. And let's see if we can solve this down for our y equals format. So first thing, let's move our 3x over. If we divide by -2, we're going to have to flip our sign. There we go. So this means our slope is 3/2, and our y-intercept is 0, -3. So we start with our y-intercept, -1, -2, -3, and our slope is 3/2, so that means we go up 3/2, up 3/2, and we can connect our dots. We need to see which way to shade, so we need our test point. I'll use 0, 0 again. So that means we would have 3 times 0 minus 2 times 0, and we want to see if that's less than or equal to 6. Well, 0 minus 0 gives us 0. 0 is less than or equal to 6, so that means we shade towards our test point this time. So our solution would look like this.